Cite, suppress, survive. The Brain's Hack for Fear Relief from the Pages of Science, published on February 6, 2025. A fascinating study led by Sarah Mederos of the Sainsbury Wellcome Centre in London has unraveled the neural circuit wizardry responsible for quelling our instinctive fear responses. This revelation, co-authored with Patty Blakely, Nicole Vissers, Claudia Klopath, and Sonia B. Hofer, suggests our brains are like retrofitted smart homes, capable of overriding gut reactions when the boogeyman is just a coat on a chair. In a breakthrough that could make even the bravest mouse feline stack up on spines, researchers discovered that higher-order visual areas in the brain, dubbed posterolateral hindquarters, PLHVAs, because who doesn't love a catchy acronym, can whisper into the ears of the fear-processing ventral lateral geniculate nucleus, VLGN, saying, "Hey, maybe chill? It's just a shadow." How it works, without blowing your mind, the brain's visual cortex, the seeing eye portion, sends VIP passes to certain neurons in the VLGN. These neurons learn to hush over the fear, a bit like telling the scarecrow it's just in a play. Basically, when a previously scary visual stimulus, like a looming threat, turns out harmless, these neurons modify their connections thanks to a mechanism not unlike post-it notes sticking to a perpetually polished board. This is done through neurotransmitter shenanigans involving endocannabinoids, the peacekeeping forces of brain chemistry. The study's method of mouse hide-and-seek employed barriers and visual threats to create learning scenarios where the mice figured out that some exaggerated shadows weren't ticket-worthy matinees of terror. This indicated that once the PLHVAs had their say, they could leave the stage, letting VLGN handle the encore of calmly. Challenges and opportunities. While uncovering an impressive piece of cognitive engineering, the study is clear that plenty of files remain unopened. The exact taxi service for neurotransmitters and how these synaptic travel guides are coordinated needs more clarity. Plus, the circuitry's exact influence on different fear levels and how various mammalian species, or maybe a skittish Broadway audience, would adapt this learning needs exploration. Nevertheless, this research points to exciting potential paths. Could tapping into these circuits help reset overworked fear systems in cases of anxiety disorders or PTSD? Researchers are optimistic, considering therapeutics or tech, like brain stimulation, could one day draw curtains on fear with practiced finesse. Outlook and implications. This research is like a masterclass in how evolved our brains are at managing instincts. The ability to quell unwarranted fear responses underlines an adaptive survival mechanism that might well be considered one of life's most practical jokes, where what we see isn't necessarily what we get or fear. The impact of these findings could ripple beyond scientific curiosity. Potentially, we're opening new therapy avenues where calming the circuit of fear in the brain saves millions from spirals of anxiety. So next time shadows grow larger than life, remember, science might just have the neuromechanics to keep the monsters at bay, not with a sword, but with the click of a synaptic switch.